So welcome back to the lesson on photons and the electromagnetic spectrum. In this case, we're going to first discuss about the equation that we mentioned in our last video, which is E equals to HF. Sometimes you can see frequency also written as a V, so it would be E equals HV. Anyways, we also computed that F or V is the same thing as C over lambda. So C over lambda equals to V. And if we substitute that in, we get E equals to HC over lambda. And all we really need to know is that H is a constant, and that's approximately 6.63 times 10 to the negative 34 joules times second. And C, as we know, is 3.0 times 10 to the fifth kilometers per second. So because both of these variables are constants, we can determine the energy of a photon by figuring out its wavelength. And if the wavelength is greater, then we would see energy going down. If the wavelength is lower and frequency in this case is higher, then energy would be increasing. Now that we have reviewed the energy of a photon, we should now address the fact that electrons have discrete energy levels, and that outer levels will have a greater energy than inner levels. So let's say this is energy, and that outer levels greater than inner levels. We can represent this on a diagram by drawing an atom with its circles, and these outer levels right here will have greater energy, higher energy than here. And because the electrons at the outer level have more energy than the inner levels, the electron at the inner level has to absorb photons to get to the higher energy level. And so once it does absorb the photon, the electron right here can slowly move up to the highest energy level, and this would just be E equals HF. We can determine the energy of a photon by using that equation. And if we see the emission of a photon, then it would be the direct opposite. So the electron would actually move from the higher energy level down to the lower energy level. Let's say it transitions from here to here. And once it does the transition, it emits the photon, and the outside environment would gain that energy while the electron jumps to the lower energy level. So this emission can occur in any direction. It's random, and many jumps can occur. So we can say it jumps to here, this energy level first, or jumps to this, and it skips this second energy level. So we can always determine the energy of the photon by getting the difference in the energy levels and subtracting them to get the final energy. So this would just be E photon, energy of the photon, is equivalent to the change of energy between the two levels. In this case, it would be E3 minus E1, energy at the third level minus the energy at the first one. And we would get the total energy, which is the frequency times the Planck's constant of the photon. So I have two rules that I want to address before we move on to the concepts of ionization and recombination. And the first rule is that electrons can't absorb just part of a photon's energy. So it's usually all or nothing. And for the second rule, we have an electron can absorb two photons that add up to the energy of a single photon. So these are two rules that you should remember when you address photons and its energy. Alright, thank you for watching, and in the next episode we will address ionization and recombination.